turbines in our CPP. Background, we are having one 150 TPH high steam pressure boiler and 30 and 25 megawatt turbines and power boilers and same as soda recovery boiler. ABC boiler connected with 30 megawatt turbine and recovery boiler connected with 25 megawatt. This is our power plant structure in our battery limits. Same ABC boiler steam goes to 30 megawatt and 30 megawatt, different extractions and goes to condenser, same 25 megawatt. And condenser cooling water, common spray pond, incoming and outgoing. This is a spray pond system in our unit. Standard practice in all steam turbines with condensers. Consistent cooling water flow rate designated per rated conditions maximum flow is being maintained all along, irrespective of exhaust steam condensing flows. Cooling water pumps hence are designed for maximum condensing flow with design margin and flow and head necessitating constant high auxiliary power consumption at all condensing loads of operation. This innovative ECS formulation and implementation, innovative energy scheme is to go in for lower cooling water flow at low condensing loads for effecting reduction in APC at lower condensing loads. APC मतलब auxiliary power consumption. Earlier practice two MCW main circulating water pumps of very high flow rated 5,500 m³ per hour each from Flowmore pumping and has been operated in a long. As the requirement of cooling water flows for the two units are far less than 3,800 m³ per hour, even at rated high condensing loads 57 to 64 TPH. Power consumption is high as 1 megawatt to 1.05 megawatt. Now, as the condensing loads in each of the turbine are much less, say around 25 to 30 TPH, it had been decided to operate one MCW pump feeding flows to both the condensers. As and when the condensing loads goes up to 30 to 35 TPH on sustained period, both the MCW pumps need to be operated. This is the pump curve, high rated 5,500 flow m³ per hour. Exhaust steam condensing flows are being split between two steam turbines. Consistent flow in both the condensers irrespective of condensing loads and flows. Invariably in cogeneration units, extraction steam per process is vary with high balance only for condensing steam. Auxiliary power consumption very high at 1.05 megawatt with two MCW pumps in operation even with condensing flows less than 50% of rated value. Moreover, the MCW pumps had been designed for 1.3 times design load. This is our design pumps in two pumps in operation and another one pump off and one pump running condition. This is the curve of auxiliary power consumption reduced drastically from the month of August. We have started trials on this. After consultation with management and as well as Siemens, we have stopped the one pump after 3 months after subsequent trials. Presently, from November onwards, consistently running with one pump only and another pump we have put it in auto mode. Reduction in MCW pump power consumption almost 0.5 megawatt per hour, same auxiliary 2% and carbon emission reduction 500 ton of CO2 per in month. With one of the two MCW pumps running flow is held. This results in flow through each the spray nozzles reduced by 50%. Hence the velocity of warm water discharge is reduced by 50%. This shall result in poor spraying in thinner mist droplets. The cooling water flow distribution from the two condensers need to be distributed uniformly through the spray nozzles covering the entire cooling tower basin for effecting better cooling. Hence is the need for adjusting the flows through spray nozzles with alternate set of spray nozzles closed. The same is being implemented. Conclusion and advisory way forward. With cooling water flow, lower distribution through stoppage and running one of two cooling water pumps, significant APC reduction and energy savings are being achieved on a sustained basis. With the demonstration, stage is now set for varying the cooling water flow is in line with varied turbine exhaust steam condensing flow by going in proposed energy efficient smaller cooling water pump with VFD in place. Through the VFD, with the help of VFD in place, it can cater to all condensing loads, high 35 to 50, medium 30 to 35, and low 20 to 30 TPH. This is cross-sector knowledge exchange. This innovative concept can be extended to all steam turbines, industrial as well as thermal power plants for achieving low auxiliary power consumption. Okay. Thank you.